To furthermore explore and understand how to use variable acceleration three formulas, we must apply it and solve it. And to understand more, here are some examples so that we will remember how to solve variable acceleration. So example number 1. If the motion of a body is defined by relation s equals 5t plus 4t cubed, s being in feet and t in seconds, determine the velocity and acceleration of the body after 3 seconds. So, s equals 5t plus 4t cubed, while t equals 3 seconds. We will use case number 1, which is displacement equals function of time, while displacement here equals 5t plus 4t cubed. So we will derive this and we will get this velocity equals 5 plus 12t squared, and we will get the velocity when we will input t equals 3 seconds, and we will input t equals 3 seconds and velocity equals 5 plus 12t squared. So 5 plus 12 times time, which is 3 seconds, squared equals 113. So velocity equals 113 feet per second. And in the question, we must find velocity and acceleration. So we have a equation velocity equals 5 plus 12t squared. To find acceleration, we must derive velocity with respect to time. So acceleration equals derivatives of 5, 0 plus 12 times 2, which is 24t. And to find acceleration, we must input time equals 3 seconds. So 24 times 3, we will get 72 feet per second squared. In example number 1, we use case 1, which is it's all about derivation. And in example number 2, we will tackle about case number 2, which is integration. Number 2. Determine the velocity and displacement of a body after 2 seconds if the motion is defined by relation acceleration equals 2t. Acceleration being in feet per second squared and t in seconds. And if it is known that s equals 4 feet and v equals 2 feet when t equals 1 second. So integrate both sides, use the limit, which is when s equals 4 feet and v equals 2 feet per second, t equals 1 second. So using this, we must integrate both sides in this equation and use the limit, lower limit 2 and lower limit 1. So we must use this formula dv equals adt, and to find velocity, we must integrate both sides and use a limit, which is our limit is lower limit is v equals 2 feet per second and t equals 1 second when t equals 1 second. So integrating this, we come up in the solution b minus 2 equals 2t squared over 2 minus 1 squared. And v minus 2 equals t squared minus 1, and combining or transpose this negative 2 here, we must find the solution v equals t squared plus 1, and then we must input when 2 equals 2 second, what is the velocity? So the velocity is when t equals 2 second, 2 squared plus 1 equals 5 feet per second. So we come up to this answer. And to find the displacement, ds equals v dt, or we come up to the solution v equals ds over dt, and then we cross multiply it and we come up to this equation, which is we must integrate to find the displacement. We must integrate both sides. So by integrating both sides, we must use limits, which is when s equals 4 second, t equals 1 second, or when s equals 4 feet per second, t equals 1 second. So by integrating both sides, we come up to this solution s minus 4 equals t cubed over 3 plus t, and then by substituting the limits or by using the limits, s equals t cubed over 3 plus t plus 8 third when t equals 1 second, the distance or displacement equals 4 feet. What will be the displacement when time equals 2 seconds? So we must input this in the given, which is 2 cubed over 3 plus time na 2 plus 8 thirds, which will we get the 7.33 feet.